Hello viewers, hello everyone, welcome to the fundamental physics videos by Ishu. In this class, we'll try to understand the most convenient and controllable form of energy, that is what we call electricity. Okay, see, compared to other forms of energy like heat energy, magnetic energy, we cannot control that much easily, like how electricity we're going to control. So just we'll switch off and switch on, so that by seconds we're going to get this electricity. By switch off, that means we can able to control it very easily, and we can conveniently use because electricity is a form of energy that we can convert this energy into any form of energy, like heat energy, magnetic energy, like whatever the form, other light energy like bulbs and all, and the sound energy when we require to kill the repellents and all. So whatever other forms of energy, mechanical energy, okay, all these forms of energy we are going to get by the electricity only. That is why we call electricity is the most controllable and convenient form of energy. So just imagine, children, if there is no electricity for 1 day or 2 days, how much we will get difficulty, right? So we cannot imagine our life without electricity. That means in a modern life, we completely depend on this electricity. Okay, see here, you see in the videos in mobiles you're operating or laptops, whatever, you need to get electricity. If you have electricity, then only you can operate all this kind of stuff. That means electricity is the most prominent. It becomes the second part of our life. Love, oxygen is a how part of life to live. Like that, it is also became one of the oxygen for our modern technology or modern life to survive in the world. Okay, that means electricity have a lot of important. So our primary job is to know how this electrical energy can be generated and how it can be controlled, okay, and how it is producing, how we can be able to convert this to different forms of energies. So how we going to produce all this electricity, so that and all we're going to understand in this chapter. This is CBSE class 10th board electricity chapter. This is also helpful for 6th, 7th, 8th grade and also 12th grade also the same chapter is there. So we will explain all the based on the view of all the viewers. Okay, please listen the video until end. Yeah, in this video we'll try to focus on main points like electric charge. Clear, children, what is electric charge? Just a second. Properties of the charges and method of charging. What is electricity, electric current, electric field, potential and potential difference, Ohm's law, resistance and electrical circuit components, and current and voltage measurements, and a combination of resistance, series resistance, and last we're going to understand one more topic, that is the heating effect of electric current and its applications also there for you. Okay, that is Joule's law of heating. All these topics we're going to cover in this upcoming video. Okay, children, keep watching. Yes, see, you can see this 4 picture here. Electrons are rubbed into ebonite rod, or we can take a 2 pair polythene balls will come up with balls like that. Balls you're going to take and charge, or we can take electrons rubbing off with the glass rod or with a silk cloth, or leaving it positively charged. So all this process, what will happen? No, they will lead the charging process will be taking place among that all. So why will this will be happen? Because see, what we taken the material, the glass rod, it is an insulator. It is not a conductor, children. It is an insulator. Because in case of insulators, no, yeah, I took a white color, so it is not visible. Yeah, when we take an insulator, when we going to rub, the what happen when we going to rub, the charges they are going to accumulate on the surface only. Whatever the charges will given when we rubbing or by okay, whatever we'll just rubbing in the silk cloth or ebonite rod with the fur, when you're going to rub, what happen, all the charges will try to accumulate on the surface only. Okay, because if it's a conductor, that will pass throughout the body, there is no enough charges to attract another body. But in case of insulators, Okay, in case of insulator, whatever we supply the charges by rubbing, all will be stored there only, accumulated there only, so that when you get this charged body to any other uncharged body, it will try to attract. That is why the two pith balls is there, no, they are negatively charged. Okay, rod is going to bring for that, they're going to attract for that. Okay, two pith balls, you can see an attraction. It is a negatively charged rod we're going to bring, that time the pith balls will going to attract by rubbing, or we can see by rubbing with the cloth, that will also attract. So all this kind of charges, what we call electrostatic charges. That means they will be present in case of insulator, the charges will be present at static, or they will be present at rest only, because it is not a conductor, right? They will be present at rest. This type of rest charge, what we call static. Rest, meaning of rest is static charges. Okay, clear children, what is rest or static charges? Okay, so when in case of conductors, the charges will flow. That is what is current electricity, they are flowing. If static electricity means they will be at rest. This is what we call static electricity. Or we can observe here, no, charges, attraction and repulsion. Negative and positive charges, they will attract, and positive charges, they are going to repel each other. Okay, I think like in case of a magnets, what you understand in case of magnets, no, same thing here also. Like poles repel each other, okay, unlike poles attract each other. So like that here, positive charge and one more positive charge, a negative charge, one more negative charge. What will happen? They're going to attract. And same time, the positive charge, negative charge, and negative charge with a positive charge, that time they're going to, they will repel, children, they're going to repel each other, and they are unlike charges, okay? Like charges and their unlike charges, they will going to attract each other. Fine, and you can see this picture is an electroscope. What I draw that first slide, no, that is an electroscope. It containing a small hole. Through the small hole in the arc, they taken on metal, okay, metal rod. So when you take your any plastic pen or something, you're going to rub and keep here the charges what is present on the pen, that will passes through this metal, and they will passes through down also like this. When it is passes, and initially the two slits, the aluminum foils will be like this attached. Okay, when you pass electricity, what happen? This will also occur same kind of charge. This will also occur same kind of charge. The like slit 1 and aluminum foil 2. The both will be having the same kind of charges. That's why they're going to split each other. They will going to repel each other. This shows the splitting nature, or shows that the metal what we take, no, the plastic has a charge. If it is uncharged when you keep, no, that time they won't split. They will be like this only, attracting. Okay, this shows the detection of electric charges by using electroscope or gold foil experiment we call. Okay, children, I hope this is clear. Yeah. Next, we'll understand some of the properties of the charge more deeper. Yeah, properties of the charges. What are the properties of the charge? We'll understand. See, first, yeah. The total charge what is there in the universe, it is a conserved quantity. That is what we call charge conservation. How will the energy is conserved? Whatever energy is there in the universe, it's not wasting. One or other form it going to conserve. Let us take bomb blast. It will conserve in the form of sound energy, in the fragment of kinetic energy of the fragment, like that. Or else we have some energy to eat food. We're doing so many works, it will going to conserve in that form, but no energy going to waste. That is what we call conservation of energy. Like this, conservation of the charge also we're going to tell. That is total charge in the universe is conserved as a constant. Like charges always, what will happen? Like charges means as a plus or minus. This set and this set, they always like to attract each other. Like charges will attract, and unlike charges, they're going to repel each other. And charges are additive in nature. Additive in the nature means it is always positive. Okay, and the charges are always quantized. We can able to quantize the charges, any number of the charges, 10 charges, okay, 10 electrons and 12 electrons. That means quantize, we're going to a number time we're going to multiply it. That is given by n into e. Charge is given by n into e. We cannot divide one charge divided by 2. Okay, half of the charges not exist. It is always n number multiplied with 1, 2, 3, 4, 5 like that. But there is where we're going to divide this charge. We cannot divide the charge. It is always multiple of n. Okay, 1, 2, 3. Suppose you have one banana, we can tell it is a one banana, two banana, three, like that. We cannot tell like a half banana, we cannot sell also, right? We cut it, it will spoil. Like the charge also, we cannot cut and tell half it. But we can tell in case of quantum mechanics, like you go for advanced physics, in case of quantum mechanics, that time we can tell the charge is again each charge or electron or proton, again made up of its three subparticles, what we call as a quarks. Okay, it will be made up of quarks. This, suppose you take proton, it is 1 by 3 plus 1 by 3 plus 2 by 3, like that. It will be made up of quark. Again, you're going to add this all the fractions, you will get 1. Okay, like that a charge will going to divide based on the quarks. But this concept is not there for you children. Quantum mechanics is advanced. You go higher classes in physics, you learn this. But your understanding and up to your level, we can tell charge is quantized. That means n number of charges multiplied by n. We cannot divide this charge into separately. Okay, where charge q is a charge, n is a number of electron, and charge of 1 electron. This value is very important when we're going to solve the problem. 1.67 into 10 to the power of 19 coulomb, and charge is relativistically constant. Okay, that means it is not vary. If you take one frame to another frame, the charge does not vary. Whatever the charge present in the system of that body, because it is an inherent property. With climatic changes, whatever will happen, it does not alter anything regarding the charge. Okay, based on the frame changes also. So please try to understand properties of the charges are: charge is a constant. We call the conservation of the charge will present. Our total charge in the universe is always constant. So I think the slide is clear to you. See, you understood now what is charge and its properties. Now see, what are the methods of discharging? So we understood by rubbing or by induction. So different methods are there for discharging. Let us see that. The first method of charging is by rubbing. Yeah, I'm going to understand. See, charging by conduction method. First I given here charging by conduction method. So what this means that when an uncharged body, like one glass rod we take, okay, one uncharged body is brought in contact with or touched with the charged body, then the charges are, the electrons are transferred from the charged body to the uncharged body. This is by charging by conduction. You can see the figure here, no? They brought one charged body. Okay, this is the uncharged body, and he have one charged body. By rubbing, he get the charge. When he get attached this body to this body, what will happen, children? Because it has, suppose you have one water tank. Okay, imagine you have one water in a tank. Like here, you small hole you make. What will happen? Hole you make and connect to one empty chamber. Okay, definitely when you release this open, okay, initially you lock, when you're going to release, what happen? All the water will move from higher level to lower level, like that only charges also. Okay, or else you pour the water in the slopey surface. You pour the water, what happen? All this water will come down, right? Or if you connect that to temperature box, one is a 10 Kelvin, another only 5 Kelvin, what will happen? The heat will flow from here to here, high temperature to low temperature, like that only charges also. When there are high charges in one body and low charges in one body, we will got into contact. That time the high charge, whatever the charges present in this, they will all transfer to this, okay, low charged body. So that is what we call as a charged by conduction. Conduction means uncharged body. This is uncharged body brought in contact with the charged body. The shifting of charges will happen from charged to uncharged. This is what we call. So you can see the diagram to here. One electron is coming from this to here, and now you can see here also little charges, here also little charges. So equally charges are distributed when you brought in contact. So this is what we call charges by conduction method. Okay, charge by conduction method. Okay, you will see this applications of all this when you go for understand little future classes. Yes, children. The second method, one is charge by conduction. Second method is charging by induction process. So how we are going to charge by induction process? In the last process, what we mean, we just brought contact. When you get contact this charged body with the uncharged body, this charges is just shifted to this. Now we are not going to contact, even though we can achieve the conduction process, that is by in the induction process the charged body object is brought near but not touched. Okay, brought near but not touched, a neutral conducting object. Neutral conducting object. The presence of charged object near the neutral conductor will polarize the charges within the conductor. See what is a polarized mode? Try to understand. In the first figure, you can see the two metal balls. Okay, two metal balls are separately insulating stand. This is a not conducting stand. If it's conducting, the charges will go to the ground. There are insulating stand. We fix it with the insulating stand, two metal balls. Now we brought one negative charge. Okay, negative charged object when we brought near it, what happened? To attract this negative charges, no? Suppose here negative charge is there. Sorry, I wrote positive. Okay, when negative charges are there, we brought near the neutral body. Neutral body means containing both positive and negative charges. Neutral body, what happened? All positive charges will come and accumulate at the surface. Because to attract this negative body, no, all the positive charges will come and attract. And see, when all positive will come this side, what happened? All negative will be reside on the another surface of the body. It is a single body, but here instead of single body, we taken two metal balls, but the two metal balls are in contact. Now what will happen? All positive charges will come to the, so now these two metal balls, imagine like this, all positive charges will come and accumulate this end, and opposite end all negative charges will come and accumulate. After they will accumulate like this, we are going to separate, because we fix it with the two insulating stands, two metal balls. No, after they will accumulate, we are going to separate them. Okay, in the last diagram we can separate. So now ball A containing all positive charges and ball B containing all the negative charges. This is what separation of charges, what we call polarize. Clear, children? This definition of this one. By induction processes. In the induction process, charged object is brought near the, but not touched to the neutral conducting object. The presence of charged object near a neutral conductor will polarize the charge within a conductor. This is what we call charging by induction process. Once again, see how you're going to done means we taken a two metal balls and connected with the insulating stand. Okay, that means charges are not going to earth. They're conducting with the insulating stands. One here neutral means both the mixed charges, positive, negative, they are randomly arranged like this in the two balls. Now you're going to bring a negative charge. What happened? They're going to polarize. That means to attract these negative charges. So all positive charges come to one end, all negative charges will go to opposite end in the single body. But we taken here two bodies. So that means in one end of this one first body, positive charges will come, and at second end of the second body, negative charges will come. Once they will accumulate like this, once we're going to separate the two balls, okay, separated, we're going to separate. That means all first body A containing all positive charges and the B containing all negative charges now. So this process what we call as a method by induction process. I hope this is clear to you, children. Okay, I think now you're clear with what is charge and what properties of charge, how you're going to charge the body by rubbing, by conduction, by induction. Okay, all these methods you are clear now. So now we will try to understand what is the electricity. So our major topic is what is electricity. No? To understand electricity, we know regarding the charge so that we learn so far. Now let us learn regarding electricity. Yeah, you can see here what is electricity means. Electricity is a form of energy. Okay, why energy? You know what is energy, children? Energy is nothing but the capacity. Okay, the capacity to do work. That is nothing but the energy. So we have the energy, so we are doing so many works. But is the electricity how doing so many works? Yes, definitely right, children. Because of electricity, this iron heaters, oven, refrigerator, air coolers, whatever we can show, all these electrical appliances, they are working because of this electricity only. That means electricity has a lot of uses it has. That is when we call it has a form of energy, and that can be easily changed to many other forms. Okay, see, electricity is converted to motion of the power. Okay, in case of motors, cars and all, okay, drilling machine and all, we're going to rotate. That is what we call magnetic effect of electric current. We are converting this to magnetic effect to run the motors. We use this electricity. And heating effect of the coil. Inside this oven, electric oven, iron box and refrigerator, we have the heating element. To heat this all, we're going to be producing electric current to do the heating effect. This is our heating effect of electric current. And in case of signals, we're going to send electrical signals like in computers, phones and radios, TVs, FM and all. We'll produce this electrical signals by what method? By electricity only, and this in communication system we only use. And again we just convert this electricity in the form of a light in case of food lights and street lights, okay, lamps and all, incandescent bulb. So many other forms of electricity we're going to convert. Okay, that means what we call electricity is a form of energy that can be easily changed to many other forms. It can be defined as the flow of electrons in a conductor. Suppose you have one conductor. Conductor means what, children? It will containing atoms, right? It will containing atoms. Many atoms it will present. When atoms are contained here, the outermost electrons, whatever we call outermost electrons, suppose you take this is the atom containing proton and neutrons are completely bound inside the nucleus called nucleon, and electrons which are loosely bound. Okay, the free electrons. Okay, one move first level they are tightly bound. If the second level, third level goes on increasing, the outermost electrons are freely bound. So we provide the less energy so that we can easily eject this electron from this atom. Why these electrons are in? Because their attractive force, binding force is there for the nucleus so that it is binding and they are rotating in an elliptical orbit. But when you provide sufficient energy from outside, okay, what will it will come out from this is what we call flow electrons. Outermost electrons are the free electrons, what we call as the free electrons in the atom, whatever present in the atom, they will move from one atom to another. They will going to jump from one atom to another atom. That means when you pass the force, when you supply force, what happens? In case of conduction, particles are closely packed. That is why you disturb one atom, other particles will keep on disturbing like that. So when you pass electricity from this end, okay, the flow of electrons will take place from one atom to another atom like this. This flow of electrons in a circuit, okay, in a conductor, what we call as a electric current. Or still you want to define still more definition, means in a cross-sectional area, suppose you take in one cross-section area, how many number of charges, that is what we call electrons, number of charges passing per unit time in this cross-sectional area of a conductor, that is what we call as electric current I. Clear, children? Electric current is given by, if you want to solve the problem, that time formula that is Q by T. Okay, where Q is, charge is quantized, right? N into E divided by T. Okay. Like this, we're going to, when we solve the problem, that time we understand this formula. Let it be, but now try to understand this nothing but flow of electrons. Now try to understand what is this electric current. Okay, the rate of flow of electrons are electric charges, what we call electrons through a conductor. So rate of flow of electrons, rate means what we call per time. So rate of flow of anything we can write it is a 1 by T. How much electrons are flowing? Suppose you taken this is a conductor, how many electrons are flowing per second? Suppose you take this area, how many electrons will cross in this area in 1 second? That is nothing but the current, amount of charges flowing per minute. More number of charges are flowing in a second, more current. Less number of charges are flowing in a current, less current, like that. So that is given by the formula I is equals to Q by T. Okay, I is equals to Q by T. And you also learned property of the charge there. Charge is quantized. So it is, we can write as N into E, number of charges, N into E by T, where I stands for the current. And see, current is a scalar quantity actually. Even though it will go from positive to negative end only, but it have the scalar quantity, even it have direction. But why it is not a vector quantity? Because it does not follow the laws of vector addition. Laws of vector addition. So many competitive exams they ask this question. Even though electric current will have both magnitude and direction. You know, children, in your small classes, you will learn what is vector. Vector having both magnitude and direction. It is called as a vector quantity, which have only magnitude called as a scalar quantity. Not like that. But here, different. If even though electric current having both magnitude and direction, but it does not satisfy. Okay, it does not satisfy vector laws of addition. So that is why we can tell. So electric current is not a vector, it is a scalar quantity. And SI unit of electric charge, see, charge it is coulomb and the time is second. So coulomb per second, coulomb per second is nothing but your ampere. Okay, coulomb per second, what we call ampere. Coulomb, you know why? Coulomb charge is coulomb and time is second. So coulomb per second. And it is measured by a device called ammeter. Okay, I'll just discuss ammeter ammeter regarding more details in coming video. So ammeter is a device to measure the electric current. We connect all, see ammeter having very low resistance, so that we'll always connect this ammeter in series with the circuit. Okay, we'll understand that. Its direction is taken opposite to the flow of electrons. Okay, charges will always flow in the opposite to the direction of flow of electrons in the flow as a result of potential difference across the ends of a conductor. Okay, this point when we understand potential difference, I'll explain once again. See why it is opposite. Let us take electric circuit. Okay, causing positive charge. Okay, let us draw an electric circuit containing battery, positive and negative, and containing some bulb to glow, the symbol of the bulb, and switch, whatever. You will connect like this. When electrons are flowing from positive to negative, okay, like this. Electrons will always move their children from negative end to positive end, but the current is opposite. Current is coming opposite to the flow of electrons. Okay, that is what we can. Direction is taken as opposite to the flow of electron. That means electrons will flow from negative to positive. Try to understand this, very important. Many times in competitive exams they'll ask this. Electrons, okay, electrons are move from where to where? Move from positive to, electrons moves from negative to positive terminal. Okay, negative to positive terminal. But the current, conventional current we call, that will be moved from where to where? That will be moved from current. Current will flow from opposite to the direction of electron, or positive to negative in the circuit. Okay, I hope this is clear to you. Yeah. See, after understanding electric current, now try to understand what is the electric field. Okay, you know magnetic field, right children? What is magnetic field? Around a magnet, let us take one more magnet. Magnetic field lines will be there, so that it will be having some its vicinity. One more magnet you brought, because of that magnetic power, it will going to attract. Okay, any magnet in north pole or south pole you brought, what else will try to attract or repel? That means to show its magnetic field around this much area. Okay, like this. Suppose you have one heater, suppose some fire is there, it is burning somewhere here, around some area it will have some hotness, right children? Or you have the sun, okay, around some distance sun will have this hotness. Okay, right, like that, existing some field, up to that field it will going to exist this vicinity, like that magnet. Okay, if you take small magnet, the field is also small. If you take very big magnet with having more power, so it will field will be more. Like this, how much? Suppose what is this field means? If you bring one more magnet, it will try to attract or repel, will happen. Okay, that is what we call magnetic field. Like that only electric field also will try to understand. Electric field, it is a three-dimensional space around a charge. Suppose here one positive charge is present or negative charge is present, it will existing field around that. That means one more negative charge will come any of this vicinity. What will happen? It will try to pull towards it. Or if one more positive charge is going to bring, that time it will try to repel it. That is based on this polarity of the charge. So that is up to what field it will try to going to attract another charge or repel another charge. No, up to that extent in the three dimension. Let us imagine like a ball. Okay, in the ball center we keep the charge. No, up to surface it will be like a field. Okay, so that is what we call electric field. Okay, about the unit positive charge, like a spherically three-dimensional, okay, space around the charge in which the force of attraction or repulsion can be felt. If you bring one more charge, test charge we call, it will attract or it will repel based on the charge you brought. Up to some distance only it will do. Again, after that distance you bring also, it won't affect. That means it field will be, it has the strength to attract only that much energy. That means, suppose imagine you are standing somewhere, you want to take some object, you not moving, you just extend your hand up to some distance only. So after that you cannot extend your hand. That means up to what extent you extend your hand, that is your field. Okay, fine. That means up to that field anything is there, you can able to take it. Okay, like that it is electric field also. Up to this extent it is there, it will going to pull towards it or repel it. That is what we call magnetic field. And electric field intensity. What is electric field, you understood, no? Three-dimensional space around a charge in which the force of attraction or repulsion can be felt. Electric field intensity, it is a force experienced by a unit positive charge when placed in a magnetic field. Okay, electric field intensity comes the force experienced by a unit positive charge when placed in a magnetic field. Suppose this is a north pole and south pole. Inside the magnetic field, lines will come from where to where? North to south. You have some north south and you have some again here north south. This is what we call magnetic field lines. They are moving from two ends. This is the field is generating. Okay. The force experienced by unit positive charge when placed in a magnetic field, that is nothing but the field intensity. It is denoted by the letter E. Okay, the SI unit is Newton per Coulomb. Newton per Coulomb, and it is a vector quantity. Electric field is a vector quantity because field, how much lines, the number of lines are moving. Okay, how many number of lines are moving per cross section? What is no direction is there and magnetic basis, so it is vector quantity. Clear, children? Yeah, try to understand what is the electric potential now. Okay, electric potential is amount of work done in bringing a unit positive charge from infinity to a given electric field. Suppose here electric, some charge is there, it will having a electric field around this, up to this extent it has some electric field. Now we will bring one more charge from infinite distance, that means very long distance, from here to here. Okay, we need to bring this object or any other charge from here to here. Definitely we need to do some work, right? Okay, how much of work we need to done to bring this unit positive charge? Sorry, unit positive charge at where? At infinity it is there. So bringing this unit positive charge from infinite to the electric field. Okay, infinite to the point, given point, this point. Okay, in an electric field, that is nothing but electric potential. Okay, children, electric potential is clear to you. It is amount of work done. Okay, what we need to do some work to bringing unit positive charge. Okay, unit positive charge from infinite distance to a given point in an electric field. In electric field. Okay, this is nothing but the what is it? Electric potential, and it is also scalar quantity because the work done. Okay, what is the work done, children? Work done is nothing but energy what we apply. Energy is again, it is a scalar quantity. We cannot tell which direction I have energy. In positive direction or north also having same amount of energy I have. Like go south also I have same energy. That means energy does not really depend on direction. So energy is a scalar. So energy in turn nothing but work done. Work done is also scalar. So that here what we are doing, electric potential is nothing but work done, bringing a unit positive charge from infinity. So both are scalar. Scalar by scalar again gives you scalar quantity only. So electric potential is a scalar quantity, bringing a unit positive charge from infinity to that point in a uniform electric field. Okay, children, this is nothing but electric potential. Yeah, its SI unit is joules per coulomb, or we can write volt. Okay, while saying electric energy, electric potential is equals to work done by Q. Electric potential we also represented with the V also. Okay, work done by Q, or work done means you know it is energy, nothing but joules, and the charge is coulomb. This joules per charge is nothing but we can write it as a volt. V-O-L-T. Okay, volt, symbol volt. Okay, because he invented this now, that is why we given his name as a volt. Clear, children? How to find electric potential we'll learn in the next slide.